Okay. Good afternoon. I have my dog in the back. He'll be joining us for the introduction to this video. I don't think I'm going to be um, starting right now. I'll do my intro and then I want to go do something. But it is day 24. It is Christmas Eve. Yeah. So happy Christmas Eve. Um, Today, the idea is um, plan for deep work number 24. Honestly, bro, can I do a find and replace? I can't. Damn it. This is not deep work. Anyways, um, two LeetCodes. Actually, I'm gonna say two to three because I think we only have three left in trees. So maybe I just do all of them today. Um, and then I would love work on the gen model for visualization app. Um, because one of the big things right now is the actual generation of ASCII is really bad. If you watched yesterday at the end, it's just bad. So I want to see the whole thing is so like in my research over the summer when I was um fine tuning models on I was looking for vulnerability detection, so I was fine tuning models to look for vulnerable code. Like I was giving it code like blocks and then giving it like a binary label of vulnerable or not. And and so I would train it on I don't know like 10,000 functions with a label, and so it would, it'd guess it would guess if it's that it'd be wrong, and so it would change the weights, blah blah blah, fine tuning process. But uh but the fine but I know how I do that in this situation, right? Because it's like it's not like it's weird because it's like how would I do that with ASCII? I guess it could be something similar, right? The only problem, not really though, because the whole thing with fine tuning for vulnerability detection is I'm looking for like patterns in code that are vulnerable patterns, right? There's nothing that even like you can find an ASCII that makes it a good ASCII problem or a good ASCII visual, right? Um, Someone's mad. One second. Sorry about that. So right, it's not like I can find a pattern on what is good ASCII and what's bad ASCII. Um, so So I want to see if there's maybe like a different fine tuning technique. Like it'd be cool if I could set something up where it's like it generates and then I manually press good ASCII or bad ASCII, and maybe it finds some correlation on what makes good ASCII and what makes bad ASCII. But at the same time, it's so weird because it's like the actual description. So right now I have it generating the ASCII visual and then like 500 characters of description underneath it, right? But that 500 characters of description is spot on. But then the actual visual sometimes is just it's not a good visual at all. Like it literally is wrong. Um, like we were doing recursion yesterday, and it was like start base case, and then it was like um, do the function end or something like that. And there was no arrows that ever went back to each other. It was all like a directed graph going down. There was never a loop, and so it's like that's not recursion. So I don't know. We'll have to look into that, and then yeah. So that's the plan. Two to three lead codes, and then that. All right. I'll be right back. All right, I'm back. Also, one other thing I might do today is rewrite my resume. Maybe. Because I should still be applying. Um, and not just waiting. Because I don't know how long these other stuff that I want to make is going to take. And so I'm just wasting time on that. So, um, so yeah. So maybe I'll do that. Or maybe not. I don't know. We'll see. All right. LeetCode time. I think we have one more medium and then two hards, right? Yup. Okay. Construct a binary tree from pre-order. You're given two integer arrays, pre-order and in order. Two lists. Pre-order is the pre-order traversal of a binary tree. In order is the in-order traversal of a binary tree. These are the same size. Okay. So pre-order is 1, 2, 3, 4. In order is 2, 1, 3, 4. I see. Output is 1, 2, 3, null, 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 4. So the pre-order is just the ordered list. In order is starting from what? The left side going. Bring up our TL draw. Okay. So what are we thinking here? One second. Sorry, I had to check the thing real quick. Um, so, so what even is, so what's the use of a pre-order even? Uh, yeah. It's not telling us. So how about this first? I want to just print, Jesus. I want to just print off pre-order and in order. Wow, it just gets the same cases. This isn't what I want. I want like an actual like. See, it says that I want to see all these test cases though. I'm just confused on like what is this? The pre-order is the pre-order traversal of a binary. What is pre-order? I mean, by looking at it, it's just the ordered nodes. But then in order, I just need some help. I don't understand. Let's just generate. I'll be right back. I need to use the bathroom. I'm back. It's been a little bit outside track. Something I was looking at. So okay, so there is something. Like I am doing this series just out of pure like trying to hold myself to just being better, and so when the opportunity arises to have an interview, I will be technically ready for it, and also just in general, you know, upping the technical skills that I have within software, and engineering, or software engineering, not just engineering, you know, and so that's the main point of this. Um, but I also thought that it'd be cool at some point, whether that is in a few weeks or that's in, I don't know, a year. I don't know. I always have liked making YouTube videos, right? I used to make when I when I played video games, I used to make like montages, um, or even if you go back to the first videos on this channel, um, or like my learning Python in 2 minutes or whatever it was. I do like doing that. It's just it takes up a lot of time, and I've always wanted to have something of much higher quality. Um, and so I had this. I saw this video a while ago, by Three Blue One Brown, where he talks about his graphics engine that he made, and it is open sourced, I believe. And so I think what I might do is look into this and start making like if I discover something through doing these videos that I think is a cool concept, being able to visualize it and make it into like a short form video, I think would be kind of cool. The point I forgot to make earlier is when I envision like my career, I envision working in the industry for my younger years, and as I get to a retirement age, if I get to a retirement age, um, to once my mind is not as sharp as it is now, and it's harder to learn and reason, and the best use of my time would be to regurgitate and teach. um, that's what I want to do. I've always believed it, in your later years, if you were if you put in the time, early on to become a part um, of a field that is about innovation, right? Which is pretty much any STEM field, then taking those years where you're not as much use in like research and try to just teach a younger generation and try to inspire a younger generation. So, anyways, all that is just to say, it would be cool to sharpen those skills of teaching and sharpen or elevate a level of quality on those types of videos. It's like I still want to do my coding every day, but it would be cool maybe like after these videos, um, if there was a topic that I thought was pretty cool, trying to learn this guy's Manum, it's called, graphics engine, and trying to visualize concepts. I know he does more mathematical, not really. I mean, everything can be described mathematically, right? But I mean, that could also be cool. Like, I'm making a visualizing app, right? What if I did something that was like, oh my God, wait, oh no, I'm actually digging up such a deep hole in my head right here. But this could be so cool. Generative language is really good with code. Like I know a lot of people say, "Oh, on big context or code bases, it's not." Okay, but on one file contexts, it's really good. Now, this guy's graphical engine, right? He has for his video. I'm pretty sure that it's showing 1,500 lines of code. AI systems, if it's one file, right, and that is the context of what's happening, it can infer all the libraries and all the abstraction after enough training. So what if I got a model, let's say Llama, right? Llama 3 or whatever's out, and I fine tuned it on my own 3D rendering uh, thing, right? That actually, you know, like here he has it where this is all kind of mathematical. I think so. Actually, I should go and look at this and see if he does have a 3D rendering thing. Um, but what could be cool is it a lot. But what if I turn my visualization app into an embedded like kind of 3D video rendering thing that goes out to a server, and that server has whatever I've built or whatever I ripped, if I ripped this guy's Manum thing, right? And when you prompt, right, you prompt visualize this. Now it does go into a second LLM to configure that prompt, but it configures it to being able to prompt a fine-tuned model on on the code of generating, you know, of models. And so it's like write the code to do this. And in that fine tuning, right, it's hard coded. So the problem with ASCII about fine tuning is that I think it's going to be really hard to find a pattern in ASCII to explain things, but it's really easy to find a pattern in code to do something, right? So like after fine tuning, it should be able to easily make a 3D block, you know, a 3D circle, 3D text, stuff like that. This is a lot more than what originally I was planning, but I I think it could be cool. Now, I want to finish just the text visualization app first, and then I'll go into something like that. But I thought it would be pretty cool. Um, just think about that. So, we're gonna open our window real quick. Be right back. I'm back. Call me crazy. I think I'm only gonna do the final medium leak code, and then I kind of want to look into this stuff. So I think I'm gonna do that. So let's go and get this leak code done. Which I still. Oh yeah. I did the ChatGPT thing. So the pre-order. This is a traversal. So like right here. Pre-order is 521869. In order would be 125689. Okay. Pre-order would be 10-4, and then 15, 12, 20. Okay. In order would be 4, 10, 12, 15, 20. Okay, I see now. Then here it would be 7, 3, 7, 3, 1, 5, 11, 14, 13, and then the other one would be 1, 3, 5, 7, 11, 11, 13, 14. I mean 13, 14, 11? Wait. Really? Visit 11. Traverse 11's right subtree. Oh. Okay, so that's just weird as fuck. What? Okay. I mean, I understand pre-order so much better than I do in order. In low key, you need both though. Well, no, in a binary tree, this has to have at least one. This has to have at least two. So that's two, three. This one has to have, if there are values, right? But that's the thing. Yeah, you do need that because you could technically this, like you could do one, yeah, two, three, yeah, then four could mean it's there, there, or there. And so with this, you know that it's going to be um two, one up to the root. So two's on this side, and then three, four. You know, three and four is on this side. And my question is how do you know that the four is on the right side and not the left side? Like, how would this? Oh, okay. So it would like specify if, but this builds left to right, does it not? But you also understand what I'm saying here, right? Like if it goes root and then left subtree, then why wouldn't I be placing the 4 in the left subtree? Okay, I'll try to do this with that in mind. So, okay, how would we do this? What would we be writing for code here? So, I mean, the biggest thing is that in order is showing us that like, okay, this is 1, right? This is the node 1. And so we know that 2 has to be over here and that 3 and 4 need to be over here and 4 is to the right of 3. What I think it's saying is if it went 1, if it went 2, 1, 2, 3, 4, then it would be this. Well, let me look at the previous examples it gave. So like here, oh, it is saying that. Okay. Oh, I get it now. That is such a weird notation. Okay. So one way we could do this is we find the root node, we append this. What does it want it to return? We want it to return a binary tree. So this gets appended to. How do you build a binary tree? I'm blanking. What? Why am I blanking? Wow. Okay. So you just set a value to none, and then you set it to a value and you set it to a node value. Okay. So my idea here is we take the in order and we go, um, and we find the first element in pre-order. Once we find that, yeah, unique values. Once we find this, one second. I'm back and I'm off the problem again and looking at this random shit. It's crazy, like how dry educational content is from really good animation and really good visuals. And I think there really is a good market coming, like that isn't solid for generative natural language prompting for visual representation. And so like I really just want to all in on this, bro. I really like this idea now of trying to integrate not ASCII but this Manum thing and trying to integrate it into this playground thing that I've been talking about. And having you be and training a model on this type of code, the Manum code, learning it myself, and then see, but it's gonna be weird because it's like usually, I've only done one type of fine tuning, and I don't know if there's other types. I'd assume there's probably is, right? Like how do you fine tune a video generation model, right? So there's got to be different types of things that it's not on my mind right now. But from my own experience, fine tuning was here's a function, here's a binary label, vulnerable, not vulnerable, right? I'm going to do all these reps that is like, okay, here is the example, label it. You labeled it wrong. This was right. We're going to go again. And it's going to find a pattern between wrong and right. So in these codes that is, you know, generating stuff, if I'm asking it to generate a scene that is showing recursion, right? Whatever that may be. And at first, this is going to be static scenes, I'm pretty sure. So like low, like this guy when I was showing, he had 3,000 lines of code. That is a full 4 minute long video, 10 minute long video of animations. I want this to just be a static image right now. Then I'll explore into like video. Um, this is gonna be fucking ridiculous. I'm so excited for this. Like this is something I'm actually excited for. Okay, I need to finish up this fucking this question so I can move on to doing the fun stuff. So what was I saying here? It's we're gonna find the root, and then we're going to append that, and then we're just gonna split this into two arrays. Left side, right side, right? So now we know what the left side is and we know how the right side is. Once we know what these elements are over here, right? I assume what we can do is we can start we need to do some type of like matching with this, right? Because this is showing us one is on this side of the root, three is on this side, and this is its right node, right? I won't lie. I want to take like a peek at how. See, he does it so simply. Obviously, I didn't get any info from that, but like that is so simple. Like, how are you doing that in 10 lines? Because in my mind, this is pretty like high level of taking this, splitting it into two arrays, pattern matching, not pattern matching, but like finding which one is the root, and then I'm gonna cheat. I'm cheating. If not pre-order or not in order, return none. Root equals tree node, okay, pre-order at 0. Yes, that's what we want. Mid is the index of pre-order at 0. That is what I was talking about. This is getting this root value. My God, look at that snow shooting up. Oh, my cursor's fucking. Yo, I'm moving the snow. Anyways, anyways, um, mid is this root dot left. So left is self dot build tree, recursively calling the entire function and saying the new root. No, the new pre-order takes away its first value and goes one past the midpoint. What? What this should be saying is, in this example where we can take this out, is this is root. Mid is the index of, sorry. Um, pre-order is what? Yeah, pre-order is this as a value. So it's 1. Okay, so the value is 1. We're trying to find the index of this, which is 1 on a 0 index scale. So then we're saying, okay, the left root of this is equal to a recursive call on pre-order, skipping the first value. So we're skipping this value. So it's going to be 2, 3. Mid equals the index of this. Index of this is 1, so plus 1. So 2. 1 to 2. So we're not looking at this 4. Right? Actually, this could actually just be the 2, maybe. I think it's just the 2. Which is the 2. And then in order is everything after the midpoint of 1. So in order is 3, 4. Now we're saying our right, our root dot right is pre-order, everything. We're defining a start, but not an end. So everything, um, pre-order, everything, but isn't pre-order? Oh, pre-order hasn't changed. So this is index 2 onwards. So index 2 would be would be 3 and 4. Wow. I understand, like, wow. And passing through in order. But so what this is doing is it's passing 2 as pre-order, right? So root is now 2 for this left node. Then there's nothing else. There's none on both of these, right? So we stop on that recursive loop. And then root dot right, we're saying, okay, pre-order at mid plus 1. Well, mid is, at this point, mid is equal to 1. 1 plus 1 is 2. 3 is the pre-order at index 2. But this is saying, okay, pre-order this and this. So this is what's being passed as root or as the pre-order list. Sorry. So this is the pre-order list. The in-order list is everything at index 2 onwards. Again, it's the exact same thing. Or sorry, it's what's in the in-order list, which everything in the in-order list is 3, 4. So now we're saying, okay, the root is equal to pre-order at 0, which, yep, it's 3. The mid is in order at the index of pre-order, which is 3. So at index 0, technically. Left out root equals pre-order, blah, 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 to that, to that. So I guess my only thing is kind of like how we know. Okay, so what happens? So left, we're not forming anything here. So we're saying this is pre-order from 1 to mid plus 1. Mid's at 0, so you wouldn't go any further. You are taking nothing. But right dot root, pre-order at mid plus 1, mid is 0, so we're at index 1 onwards. So this is just 4. So now we're passing through. Wow. Wow. That is quite. So that is quite the fucking. So if pre-order or in order is none, we just return none. Otherwise, we want to say, okay, so the root is equal to pre-order at 0. The midpoint is equal to in order dot index of pre-order. Or no, this should just be root at the index of root, right? Oh. This is a root. Sorry, a tree node. I forgot we were doing this as a tree because we need to return root at the end. Um, and so this will have to be equal to pre-order because we can't do the index of a node and whatever. So that is our root and our midpoint. So now we just want to do our recursive calls, right? We want to say, okay, the root dot left is going to be equal to build tree. So build tree, that first list, pre-order, is going to be the pre-order. I think it's at like 1 plus. Or no, is it pre-order plus 1? Sorry. Yeah, no. Pre-order 2 mid plus 1. Why is that again? Oh, self.build tree, sorry. So when we're building out this left node, it's build tree with pre-order 2. Okay. Okay. So it's from 1 to mid plus 1. And then as our in order, we're just saying in order um up until mid plus 1 or up until mid? Up until mid. In order in this situation is up until mid. So this is the but this is mid. I'm gonna watch the video on this actually.
Hey everyone, welcome back, and let's write some more LeetCode today. So today let's solve a pretty fun problem: construct a binary tree from a pre-order and in-order traversal. So we're actually given
It took me
two
2
integer
days to
arrays
solve. Jesus Christ.
representing one, the pre-order traversal, and two, the in-order traversal of a binary tree. And our goal is to take these two traversals and the orderings of those nodes and then reconstruct basically the original binary tree that the traversals are from. And it is technically possible. These two traversals have all the information we need. We just need to take that information and then deconstruct it and then reconstruct this 20, add 20 to our pre-order, go left, we see 15, add 15 to the pre-order. 15 doesn't have any children. Now we go to the right subtree, 7, so root node, and then we take care of the right subtree with in-order traversal. That's the general order, so let's validate the in-order traversal of this tree. So we're...
Oh my God, I'm so dumb. Yeah, it's just given every single root, right? And it's right and left doing in-order traversal, which would be 15. Okay, that makes so much more sense. Okay.
Two main facts that we're going to be using to construct this tree. So the first fact is that the first value in pre-order traversal is always going to be the root, right? We remember when we do pre-order traversal, right? We're always processing the root first. So if I was taking the pre-order traversal that we're given, right, we remember this is the pre-order traversal that we're given. The first value in pre-order traversal is always going to be the root. So this is the first value, 3. It's guaranteed to be the root because that's how pre-order traversal works. The first value in pre-order traversal is always the root node. Now we don't know about the rest of these, right? But we can recursively construct now the left subtree and the right subtree, right? We're done with this 3, right? Now our goal is to reconstruct the left subtree. Hey, lucky for us, the first value here is always going to be the root of the left subtree, right? Because that's how pre-order traversal.
What do you mean that's always going to be? What happens if this is 15, 9, and 10? Would this not be 3? Oh no, it would be. Wait. My
Works,
head,
right?
bruh.
So that's one thing that we're going to use. The first value is always going to be the root, and then we can take the sublist, right? We can remove the 3. We don't need to look at it anymore. Then we take the sublist, and then basically we're going to do this recursively. That's what I'm telling you. Okay, we can construct the root, but we need more information than that, right? And then let's say we're done looking at this 3 now. I want to take this array, right? And I want to know which values are going to go in the left subtree and which are going to go in the right subtree. From looking at the actual tree itself, we know the answer, right? We know that this is where we're going to cut our list, right? The 9 is going in the left subtree, right? These 3 values are going in the right subtree. But how can we determine that? Well, that's what we need our in-order traversal array for. Okay, so now let's take a look at the input array we're given for the in-order traversal. And by the way, let me just mention that every value in the traversal is guaranteed to be unique. That's true for both of the traversals, the in-order and the pre-order. Every value is going to be unique because every value in the tree is going to be unique. But okay, so far we know that this first value 3 is going to be the root, right? So now let's find 3, right? We know 3 is the root, right? So we removed it from our first list basically, right? But now let's find it in our in-order list. We find it's right over here. 3 is in this index, right? So we know we don't need this 3 anymore, right? We already created that node. But so now what does this in-order array tell us? Notice how this is convenient for us.
I just want to see the code.
Until we're finished with every single node that we need. So now let me actually show you the code. It's actually very short, less than 10 lines. Okay, so as I mentioned, this is a recursive algorithm. So we always want to start with the base case, and the base case is going to be, what if we don't have any nodes to traverse through the two arrays that we're given? That means we can return null, or basically we don't have to create a tree. So if pre-order is empty or in order is empty, then we can return null. We have no values, so we don't need to create a tree. We can return null. Otherwise, we're going to create a tree node, right? And what's the value of that tree node going to be? Well, it's going to be the first value that happens to be in the pre-order array, just like I showed you, right? Always going to be the first value, so it's always going to be index of 0. And then whatever that value was, we want to find the position of it in the in-order array. So in-order.index, so we want the index of that value, pre-order of 0, and we're going to get it in mid. Now this is the part where we're going to build the subtree. So root.left, let's create the left subtree, and we're going to do this recursively as I mentioned. So self.build tree, we're calling the function that we're inside of. And the convenient part about Python is we can do sublists, so that's going to cut down our code quite a bit. So we need to pass in the new pre-order and in-order arrays, or the subarrays more likely. So pre-order, what are we going to pass in for the left subtree of pre-order? Well, mid tells us how many nodes we want the index of.
This is making more sense. Okay, so we already have our root at 0. So if this is, we're building out the left side, right? Then all we want is the pre-order, skipping that node that we've already appended to root up until that midway point, right?
Basically, the value of mid tells us how many nodes we want in the left subtree. So what I'm going to do is, for pre-order, we're going to start at index 1. We're basically skipping the 0 index because we already just created a node for the 0 index. We're starting at index 1, going all the way up until mid plus 1. In Python, this mid plus 1 is non-inclusive, so this subarray is really just a pre-order from index 1 to mid. So that's what we're doing, and we're going to pass in the in-order portion that we need as well, and that's just going to be from the beginning up until mid, but not including mid, right? This probably makes more sense if you go back and look at the picture, but basically we're just creating the appropriate sublists that we need to create the left subtree. We're going to do basically the exact same thing with the right subtree, and I would encourage you to draw this out yourself to basically reinforce what you're learning or watching me do right now. So to build the right subtree, we need every value after this sublist, right? So we can just say starting at index mid plus 1, going until the end of the list. That's how you do it in Python. We're starting at mid plus 1 and going until the end of that sublist, just like I showed in the picture. And for in order, we can actually do the exact same thing. We want every node to the right of mid in order, right? From our in order array, we want every value to the right of this index mid. So we can do that with mid plus 1, starting at mid plus 1, and then going until the end of the array. So now let me close this function. And so this is
Okay. The in-order stuff, the pre-order stuff, I understand. Mid-order is still a little fuzzy. I mean, so pre-order is just the exact opposite, right? It's from mid plus 1 onwards to the end of the array. And then our in-order function, or array, sorry. Our in-order array is going to be from, what did he say? Like this? Or nah? Did I fuck that one up? Oh no, it's the exact same thing. Might be. So that's just it. I return root. Eh. What I do? Um, okay, I can just so the it's not the same exact code. I don't think this is changing anything, but or it's changing everything. Okay, my bad. My bad. Okay, this one was fucking just not a medium. Uh,
Literally all you have to do, the reason it's so easy is mainly because I'm using Python, but you could do this code without Python. It would probably just be a couple extra lines. You might need to pass in a couple extra parameters into this build tree function, basically just these indices that I'm doing. You might not be able to create sublists, but you can at least pass these.
yeah, I mean, quite difficult. I won't lie. Um, that was definitely the most difficult tree problem I've had thus far. Um, yeah. Um, yeah, I don't know what else to say. It was quite a difficult one, but I'm gonna stop there with That's no fun to play with. I actually need to go do something real quick, and then we'll be back, and I can actually work on the thing I wanted to work on today, or the thing that I thought of on my break earlier, and now I want to work on full time. So I will be right back. Okay, I'm back. I'm sorry, it has been a while. Video is gonna be actually shorter than I wanted it to be, because I need to go do something in like 20 minutes. So what we're gonna do is we're just gonna, I think I'm gonna, I think I'm gonna work on this tonight. Not the actual like coding, I don't think, but looking into this idea of like looking into the code of um Manum and just seeing like what can happen. So let's actually talk with ChatGPT a little bit here and see how this might look. So not sure if you know what man is it Eum? No, just man but my idea. Okay. See, this is what I'm gonna have. Okay. This is something I've always wanted to do is like okay, fine tune it on like automatically, like what I provide. And this is gonna be something that's gonna take a while, I assume, right? I can get like a base, like a very raw form, because I would assume ChatGPT has been trained on some of this code, right? I assume I can get it to do basic standstill images of like generate a cube, generate a circle, something like that, right? If I can just get the graphical interface integrated into the app, and when I prompt it, it goes to ChatGPT, writes the code, sends it to a server, and then the server reflects that. That in itself is just a win. And so that is going to be the main focus going forward these next few days. On the other end of that is now fine tuning it to do bigger ideas, right? Giving it thousands of examples paired with, you know, um, paired with, so I mean, it's gonna be a lot. Obviously, I can do ChatGPT on the generation side of things, right? I can do a lot of examples, but I say my biggest idea here is then to just do. I think the best thing is doing fine tuning on maybe 100 examples, right? It's not going to be the best, but let's say just 100 examples. Um, and then doing human feedback, right? And so I'll give a prompt that wasn't in the training data, right? And then I'll see what it outputs. And I will say, no, like that wasn't good. And then or yes, that was good. And I literally just manually go through one by one. And the ones that are good, maybe I add to a data set um, of like good ones. And then let's say every day I go through 50, right? And let's say after a month, I then will have a data set that I can train on. Well, isn't the whole thing about human feedback is that like the only thing we care about is weights, right? We only care about weights. So actually what I'm saying is stupid. It would just be like human feedback. So it could be when this app is in like a beta version or whatever, if you get a generation that you think was really good, you can say this was really good. Or if you think there was something really bad, maybe it can tweak the model. I don't know. I don't know. It's something that's going to have to be tested. There's still so much that needs to be tested. One second, I'm checking this DM. Yeah, there's still so much that needs to be tested. So this was what I was looking at was this community version, right? And so like this, for example, this is animating a circle, and then actually let's see, installation on Windows. And then this afterwards. So the idea right now I'm doing ASCII generation. I want to change it to doing this code generation, then rendering it, right? Well, this is installing. We can look at the docs for tutorials. Quick start. So you create a folder import manum, do all this. This is in scene.py. I do manum, whatever, scene.py create circle. So you have to call the class as well. Okay, so it out. Okay, that actually makes it easier, right? Oh, I don't want this. That actually makes this quite easier. Nice. In the fact of, okay, so let's go to OneDrive, desktop, code. Oh, whoa. No way that just opens that. CD code. And then I want to do like an echo, or actually, let's make the directory of I would say I want to make the directory of just manum, right? And then I can say cd manum and then echo um circle.py. Does that not work? Neovim. What about in here? Echo um circle.py. Perfect. Okay. So let's go here, open up circle.py. Give me this code. Okay. And then what was it? It's this, but oh, but this isn't scene.py. This is circle.py. Interesting. Oh, I never saved this. My bad. Okay. So it does that. So, okay. So now comes the big hurdle of getting this MP4. Um, so if I open up another thing of this and I CD um into OneDrive, CD into desktop, code visualizer, Neovim, I want CD into server. Oh my God, CD. It's gotta be an easier way to do this. I mean, I can do CD, OneDrive, desktop, code, code visualizer, NeoVim. That's faster. And then C client, npm start, and run the same here. Whoa. What did I say? Oh, no. I need to do um Python app.py. Okay. So right now we have like make a, by the way, I realized you couldn't see this yesterday. Make a binary tree with 10 nodes and show a depth first search. Visualize this processing. Bam. Right, we got 10 nodes. It shows how it's going and then explains it. Cool, right? Um, but now I have the idea. God, you know what would be sick? So it would have to be something, right? Where we have, it would be the same HTTP, like we could do an HTTP server in that server. So when I do visualize this, it goes to the server, it processes something, and then it returns something. How could I do this with an MP4 file, right? How to, like, I guess I can ask ChatGPT for this. So it would be like, how can I, well here. So if I go here and I go to what desktop code Manum in media images circle nothing, but I go to video circle this, here's our video. Can I make this higher quality? QK. Tutorials, output settings. Oh, quality high. Ah, that is what I want. Okay, very nice. Amazing. Okay, so let's go to ChatGPT and say, Let's just do this for now. So what is this? This is a flask. Okay, so what I can do is, so first um let me go out and just do git status, git add all, git commit message working ASCII version of the app, because I might come back to this. Git push origin main. Okay, so now what I want to do is I want to go especially to this backend. And so this is all working with ASCII and prompting. What I want to do is add this type of stuff to it. So I forget, how do you make block? Is it ba ba ba? No. Ba ba ba. Aha. Gotcha. Okay. Beautiful. So the idea here, I don't. So what is the HTTP stuff doing here? Hmm. Well, so right now I'm defining an HTTP server with a post method. That's talking on the front end. So I think what I can do, I'm actually going to. I do need to go because it's 7:30. So what I'm going to do tomorrow and maybe tonight, I might when I get home, or I might tonight, later tonight when I'm free, I might dive into this a little bit. But um, but for now, the idea what I want to go with is adding to our HTTP server or making a Flask backend server is going to be the server runs the command on the inputted code, right? Um, it takes that code. So what we can do actually right now is the the input that we're right now asking for generation to for 4.0, that input we can make it so I can just copy and paste direct code into there and it will visualize it. That's a good first step, right? I think one of the biggest things is I really want it to be flush. Like I want it to look like it's like literally in the application. I don't want to just be, oh, here's a video. That's not what I'm trying to go for. So if I can't get like a background color matching thing going on, like it just blends into like the dark background, I might have to see if I can export the video as a with a transparent background. Um, and because this is open sourced, I definitely can. It might take a lot of work, but I want that. I really want that. I want it to be transparent and just sit on the screen. I want it to feel magical, you could say. So so I need to find a way if I have to add it to the open source project, which will be a lot of work, but hopefully I can figure out a way to just make it look like it's just sitting on top of everything. Um, yeah. Um, I think that's it. LeetCode went horrible today. That was such a hard question today. Um, and this, I'm really excited for this. I won't lie. I may even not even do like LeetCode tomorrow and just dive right into this. Not gonna lie. I'm really excited for this project. So yeah. We'll see. We'll see when tomorrow comes. Like I said, I might work on this tonight. I might what I just said do tonight as a proof of concept, and then show you tomorrow, and then we can go forward from there. Um, but yeah, I will see you tomorrow. Bye.